cannot join here can watch on YouTube. So I will share the link in the chat box as well. So if any of your friends could not join this live session on Google Meet, then they can join in YouTube also. So welcome all of you. Today we are going to take the first lecture of the Deep Learning IT Roper live classes. This is actually for the problem solving based on the week 1 lecture. So already week 1 lecture is uploaded on the NPTEL portal. So you all can access there. And I hope that you all have seen the week 1 lecture before attending this problem solving skills. Even if you have not seen, then you can learn the basics concepts from this live tutorial session, because we will also try to cover the basic concepts using this tutorial session. So this course is taken by Professor Mitesh M. Khapra, which is from IIT Madras, and Professor Sudarshan Ayyanagar. He is from IIT Ropar. And I am Abhishek Thakur, a Prime Minister Research Fellow at IIT Hyderabad. I will be taking weekly live classes, which will be just like to building the concept through problem. So it will be tutorial classes basically. So today we will see like whatever we have studied in week 1, some of the important questions based on that, and also we will try to visit the concepts accordingly. And one more thing, like anyone who could not join this, I have already shared the YouTube link, so you can share to your friends, whoever could not join this meeting. So coming to the first thing that very important in the neural network, it started from McCulloch-Pitts neuron. So this is the basic neuron where function G is there, which aggregates all the inputs and which gives to function F, and F takes the decision based on the aggregated inputs by G. Okay, so this is the basics of MP neuron. So our first question, okay, first question is, given the following representation of an MP neuron, what is the role of function G? So we know that our function G aggregates all the input. Okay, so G is basically here summation of xi, where I belongs to from 1 to n. Okay, so the correct option, which is the correct option, you can also reply in the chat box. Correct option for this question. Yes, correct. The option B is correct. Here you should remember three things about McCulloch-Pitts neuron, that we have G that aggregates all the input, and after that F takes a decision based on the aggregated input, means our Y that is based on F of Gx. Okay, so F is a function that depends on Gx, and I request all of you to join on time from the next class, because I have to admit each of you, so it's just like a hindrance in between the class. So okay, understood this question. This is just a basic McCulloch-Pitts neuron. I will just little explain. In this, various inputs are given, x1, x2, and xn. And the function g integrate g takes all the inputs and give to f, and f takes the decision based on the gx. Okay, so f is a function which depends on gx. And what is our gx here? Gx is summation of xi. I is equal to 1 to n. And still many people are joining. Okay. So here y gives the output that is either 0 or 1. This is binary classification because it have only two classification levels, that is 0 and 1. So this is about McLaughlin-Pitts neuron. So coming to the next question, most of you have given the option B, that is correct. Now we will see what is perceptron and what are the differences in between perceptron and McLaughlin-Pitts neuron. So there are some challenges in MP neuron, that it takes only the input that is like that is 0 or 1. Okay, it does not take real value inputs, and still people are joining. Don't know. Okay, so I think most of them joined. So right now I don't think anyone will join. Okay, so what are the still yours? So what are the challenges in MP neuron, that it takes it does not take the real input value. It takes like logic gates function like 0 1, such kind of inputs it takes. Okay, so these real input can be taken in the perceptron model. So next question we will see, accordingly we will discuss the concepts based on the perceptron model. So first I will ask all of you to answer. After that I will solve the question. Second question is, what are the advantages of single perceptron learning over the McLaughlin-Pitts neuron? So there are four options. First is real input. Second is weights for each input. Third is hand coding the threshold is not required. And fourth is all of the above. So in this, like there some confusion. Most of the people are answering A, B, C, and D. So the correct option is option D, all of the above. We will discuss each point one by one. So first we'll see here, like this is our McLaughlin-Pitts neuron, where our output y is equal to 1 if the summation of all the input is greater than 0. Okay, and that is equal to 0 if summation of xi is less than 0 or some threshold value. But in perceptron y is equal to 1, we will see how this formula came. I is equal to 0 here. Still people are joining, and so in perceptron there are two three different things what we have to see, and that is a advantage of perceptron over MP neuron. The first, that all the inputs x2 x3 and dot 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 xn have some weight. What is the advantage of this weight? Like now 54 people will have joined. Okay, so what is this advantage of weight? That various input determine the our output. So some inputs have like higher. Still some people are joining. So some inputs have a higher value to decide output. Like say you have to go to play. So it depends on like some output is the time. So if time is in the evening, then the weight of that input is high. Okay. So in that way, in weight is assigned to each inputs, and higher weight will be assigned to input which is having higher priority. So weight is assigned Weight is assigned to each input. And what is the advantage of this weight? Like output is taken based on the priority of input. Like some inputs are very useless, like that does not affects the output that much, that will be having very low weight, okay? And some inputs are at very high priority, that will have high weights, okay? So there was no weight concept in the MP neuron. So the option B is correct because it is giving weight for each inputs. Also, in this perceptron model, our inputs can be real. Like in MP neuron, the input can be 0, 1, something like that. But in this, it can be any real value, like in the fractional part, also in the decimal value 0.5, 0.6, in this way. Okay. And the third, hand coding of the threshold is not required. Here, threshold depends on our bias. Like one more weight is there, that is W naught and X naught. Okay. So this depends on our bias, W naught and X naught. So I will just write this is Y. So what happens? Y is equal to 1, means the output is 1 if our Wi I is equal to 1 to n is greater than equal to theta. Theta is our threshold value which determines our output. Okay. So and Y will become 0 when Wi into Xi is less than our threshold, that is theta. Okay. So we can also write this. We can also write this in this way, that Y is equal to 1 if Wi into Xi minus theta is greater than 0, and Y is equal to 0 if Wi into Xi minus theta is less than equal to 0. So, sorry for the interruption. Yeah. This one small confusion. That greater than equal to or less than equal to both in 1 and 0. There is still confusion. If the threshold is greater than or equal to 0, then Y will be 1. If it is less than theta, Y is equal to 0. Thanks. Yeah, yeah, but I'm just rewriting the equation. First, first we have taken. So we are coming to the final derivation. So you just wait for some times, then your doubt will get clear. So here Y is equal to 1 when Wi Xi. You are saying in that case, when here we have taken I is equal to 1 to n. Okay. But you are talking about this part, that this threshold means this Wi into Xi is greater than 0, but here you see I is equal to 0. So this concept only I want to teach through this question, that how this came. Okay, your doubt got clear. So no, no, sorry, that was left by doubt. You do first. Y is equal to 1 if the summation is greater than or equal to theta. Y is equal to 0 if the summation is less than theta or less than or equal to theta. Yes, yes. Is it that equal to will also? No, no, equal to will not come. Yeah, yeah. Thank you for figuring it out. Equal to will not come here because we have already taken in the first case equal to. So if you take in the both the case equal to, then it will have a contradiction. Okay, thank you.
So the submission will be from zero or from this one,
So,
because we are using weights also,
so we
right?
are using weight. So first, it like in this formula, it's starting from one, and now we will proceed to the next steps. In that, we will include the bias weight, that is W naught. Then we will use from I is equal to 0 to n.
Okay.
So like theta is depending on our x naught and W naught. Okay. So we will take theta is equal to, here I is equal to 1 to n. Here also I is equal to 1 to n. So we are getting y is equal to 1 when wi into xi minus theta is greater than equal to 0. So we can also rewrite it as y is equal to 1 if I is equal to 0 to n wixi greater than equal to 0. What we have done, we have taken w naught equal to minus theta here, okay, and x naught equal to 1. So this minus theta term, here this minus theta term, this is equal to w naught into x naught, because x naught is 1 and w naught is minus theta, okay. So now we can write from I is equal to 0 to n. Understood how this came? Because we have taken the initial bias weight also in the consideration. So this is the final equation for the perceptron model. So here hand coding the threshold is also not required because it depends on W naught and X naught. So all the options are correct here. So like most of you have told option D. It's good that you are following the lecture because these questions are from lecture. Now we will see one more question. Question 3, that a perceptron has input W1 is equal to minus 2.5 and weight input 2, that is 1.5, input x1 that is 0.5 and input x2 that is 2.5, and it have a threshold value that is t is equal to 0.3. Okay. Now here it is written that W1 is the weight assigned to x1 and W2 is the weight assigned to x2. So they are asking what output does it give for these inputs. Okay. So we'll solve this question. This is very simple question. Uh, I want you to first reply in the chat box what will be the answer. Simultaneously, I will also solve. Our weight input W1 that is given as minus 2.5, W2 is given as 1.5, X1 is given as 0.5, and X2 is given as 2.5. So what output does this perceptron model will give? So the out W1 X1 plus W2 X2, like what is the formula we have seen? Wixi is greater than threshold, then output is 1. If Wixi summation is less than threshold, then output is 0. Okay. So our Wixi summation will come as, here I is equal to 1 to 2 is there. That is equal to minus 2.5 into 0.5 plus 1.5 into 2.5. So it will be minus 1.25 plus this will be 3.75. So it will be 2.5. So now this is greater than our threshold that is equal to 0.3. So what output it should give? It should give output as 1. Okay, and here this t is equal to 0.3 is w naught into x naught. Okay, in the last example we have assumed that w naught is minus theta and x naught as 1, but in this example the product of w naught x naught is 0.3, that is the threshold value. Yes, Saurav Srivastava, you have raised your hand. What doubt you have?
Yes, I have just a doubt with whether to consider this summation from zero or not scale. Because we
Hmm.
are considering this base as corresponding to zero.
Yes, yes.
So now it's clear.
Okay, thank you. Because this T is only the W naught X naught. So that we have taken on the right hand side of this inequality. So here it will get our. So now we will see like for different number of inputs, like if we take more number of inputs, then which decision boundary we should take here. So this is a very simple question. But along with this, we will also go through some of the concepts. So you just reply the answer for this. Okay, most of the people are answering B. That is correct answer. Because in this question, it is given that pick out the one which best describes the decision boundary that a McCulloch-Pitt neuron model learns when the number of input is 2. Okay, if the number of input is 2, then what will be, and the inputs are binary value in McCulloch-Pitt's neuron, not a real value as in perceptron. So what will be the possible combination of input? Like this will be 1 0 0 0 0 1 and 1 1. Okay. So now in this question it is asking which decision boundary will classify the sets of inputs in the two outputs. Like if you draw a line from here to here, so this can easily classify that this part is output equal to 0 or this part is output equal to 1. Okay, so a line can easily classify. Now what is the optimal line for this answer? This is like equation of this line. What is the equation of this line? X1 x naught plus x1 equal to 1. Okay, now in the same question, let's suppose if three inputs are there. If three inputs are there, x1, x2 and x3. So what will be the decision boundary? Line, plane? Yeah, correct. It's plane. Now there are 8 points in this. So these are the 4 points. So the plane will intersect 1 0 0, 0 1 0 and 0 0 1. Because below this plane only one point will be there, that is 0 0 0, and after this it can separate out just like the OR function. In OR function, when all the inputs are 0, then output is 0. Okay, if any of the input is 1, then output is 1. Any input is equal to 1, then output is 1. So here if three inputs are there, then plane. If more than 3, then that will be the hyperplane. Okay. So if no doubt, then we can move on to the next question. Now this is just like a week one lecture. So this is just a basic lecture. So that's why we have lots of basic questions. As we will proceed to the next weeks, we will have more number of advanced questions. In those tutorials, we will solve very advanced problem from different textbooks also. So in week one, only Maclock Pitts and perceptron, single layer perceptron neuron is taught. So there will be some basic question. You can easily solve these questions by yourself. So question fifth. Consider an OR function MP neuron with three inputs, that is x1, x2, x3. The number of input points can be 8. Okay? Because with three inputs, we can have 8 number of input points. And the MP neuron tries to learn a decision boundary that is a plane. As we have seen in the previous example, that the for three input, we can classify the output using plane in MP neuron network. So how many points out of this 8 point lie below the plane? So we have already seen in the like previous question here that there will be only 1.000 that will lie below the plane containing all these 3 points, that is 001, 100, 010. So the equation of this plane will be x1 plus x2 plus x3 is equal to 1. This means this will intercept on each axis this plane at 1. Okay. So this is our 100, this is our 010, and this is 001. So here this is the only point which will lie below this plane. So only one point lie, that is 0 comma 0 comma 0. Okay. So this was just a basic question. Okay. So now we will move on to the question number 6. So in previous question, most of you answered 1. Yeah, that is correct. I can see, yeah, many people answered 1. So now we will solve one example. In this, it is given this question that in the perceptron learning algorithm, the positive points are those that are labeled 1. Okay. So positive points are labeled as 1 and negative points are those that are labeled as 0. Now what is the angle that any positive point vector makes with W? Okay. So in this question, I have the diagram here. So this is our axis x1, okay, and this is our axis x2. So there are sets of positive and negative points in our data set. So the positive points are denoted as P1, P2, P3, okay, and the negative points are denoted as N1, comma N2, comma N3, okay, and the decision boundary which can separate the positive and negative classes, that equation is given as WTX is equal to 0. This means W1 X1 whatever is the weight and whatever is the input, the dot product is equal to 0. Okay, so this line will pass through origin because when all the inputs are 0, then it will become 0. So this line will pass through origin. This is our WTX is equal to 0 line. Now we will see the perpendicular, the normal to this line, that is given as W vector here. You can see this is the W vector that is normal to this line. WTX is equal to 0. So what in this question asked? Now what is the angle that any positive vector makes with W? So this is our W vector. So all the positive vectors will lie in this part of the above this line. Okay, this WTX is equal to 0 line. It will lie above this line. So if any points lies here to here, whatever angle it will make from W is less than 90 degree, because the maximum angle which can make it is a 90 degree. Okay, so like this point is less than 90 because this is in between. WTX is equal to 0, and like P3 point lies between W vector and WTX is equal to 0. So whatever lies here, that will be less than 90 degree because that is lying just above the line. So for P3 also it is less than 90 degree. For P2 also it is less than 90 degree. And for P1 also it is less than 90 degree. And for negative points in the data set, what will be the angle between the W vector that is normal to our decision line and the negative points? Can anyone tell in the chat box? What will be the angle between the W and the negative points in the data set? Yes, that will be greater than 90 degree because see, from here to here, this is 90 degree. Okay. Now anything adding to this 90 degree will become more than 90 degree. Okay. So now coming to the question, it will be making less than 90 degree. Okay. For positive points. And for negative points, it is greater than 90 degree. So you have understood this. Okay. So now we will move to the next question. And I hope all of you have seen the lecture. Then these questions will be very easy for you. And one more thing, how we will find the angle, like any angle alpha. Angle alpha will be found between W and X, that is equal to cos inverse WTX divided by, we have normalized W and X because we know that dot product W dot T dot X is equal to W bar, sorry, mod of W, mod of X and into cos alpha. So from here our cos alpha will be Wt dot X divided by magnitude of W and magnitude of X. Okay. So alpha will be cos inverse WTX divided by magnitude of W and X. And here in perceptron we also know, just I am expanding these things so that you will get to learn the concepts. because this live session is basically for building the concept through questions. So our output will be 1 when this WTX will be greater than 0. Okay. So this means whatever point lies in this is WTX is greater than 0. So this green shaded point. So this is the green shaded point. And Y is equal to 0. Here you can give the equality sign when WTX is less than 0. So now we will see the next question. This is based on McLaughlin-Pitts neuron. For which of the following gates the threshold value is 3 for 3 inputs? So in this question, 3 inputs are given x1, x2 and x3. What will be the answer? Please write in the chat box. This is our MP neuron. So in this it is saying what will be the threshold value for 3, means the threshold value is 3 for 3 inputs. Now which logic gates it represent? So as we know, from x1, x2, x3 there can be 8 inputs. Okay, and if it is and here it is saying that the threshold value is 3 for the 3 inputs. So there is in AND gate, among these all 4 gates, when the all the input is 1 1 1, then the output will be 1. So threshold value is 3 when this is a AND gate. Okay, because in AND gate, except all the input is not 1, means except all the input is not 1, then the output will be 0. Like if any of the input is not 1, then output will be 0 in AND gate. So this is AND gate. What is our G? G is summation of xi. So here that is x1 plus x2 plus x3. So in AND gate, when all the input are 1, then this summation will be 3. Okay. So G is equal to 3 is the threshold. So that is less than, greater than or equal to 3. So what will be the correct answer? Answer is A. All of you have correctly wrote the answer in the chat box. One more thing I would like to ask all of you, like in this, okay, for OR gate, for AND gate, the threshold is 3. For OR gate, what will be the threshold? Okay, 1. And for NOR gate, 0, correct. And for XOR gate, for NOR gate, it will be 0. I guess some one answer is also there. Because see, nothing. Because XOR gate is not linearly separable. Okay, we cannot separate XOR gate linearly. Correct. But for NOR gate, some of the answer was 1. I will just like to clarify. So this is our AND gate. And let's suppose this is the NOR gate output. That is why NOR we write. So output will be 1, 1, 1, 1, 1, 1, and 0. Okay? No, no, it won't be like this. For 0, it is 0, that will be 1. And for everything, it will be 0. Because NOR is the complement of OR. So whenever output is 1, then here means whenever output is 1 for the OR, then output for NOR will be 0. Okay? So this will be 0, 0, 0, 0, 0. So now we will see like how this XOR cannot be linearly separable. Like for these three we have seen, like we have XOR gate. XOR gate output is, as we know, X1, X2 and output. Whenever input is 0, 0, output is 0. 0, 1, output is 1. 1, 0, output is 1. 1, 1, output is 0. There is one shortcut in XOR gate. Like when number of input equal to 1 is odd, then output is 1. When number of input equal to 1 is even, then output is 0. This will be helpful when we do XOR gate for 3 inputs or 4 inputs also. So here we will see 2 inputs only, that is very simple. So you can see what are the negative points, that is when output is 0. So our and negative points are 0 comma 0 and 1 comma 1. So these are our negative points. Okay. And what are the positive points? Positive points is those for which output is 1. That is 0 comma 1 and 1 comma 0. So this is our positive point. So is there any line which can classify or which can separate the positive and negative points separately here? No. Yeah, most of the comments are not with single perceptron. That is correct. It requires multi-layer perceptron that is taught in the week 2. So that we will discuss later. But here we will see, is there any line which can separate? If we take this line, then it cannot separate, like this side also negative points are there, and this side of the line also negative points are there. Okay, so no line, no decision boundary, no decision line can separate the negative and positive class. Okay, so here XOR is our not linearly separable, and we'll also solve one question based on that. Now coming to the question number 8. So in this 8th question, what it is given, what is the thresholding parameter for the MP neuron for the given Boolean function? The Boolean function is x1 and x2 and x3, and this is not of x4. Okay. So what will be the answer for this? So let's make a MP neuron model here. There are four inputs into this. That is x1, x2, x3, and x4. But here x4 is inhibitory. Means whenever x4 is 1, the output will be 0. That is the dominant. Someone raised the hand. Chandan Kumar. What doubt you have?
Then this was
Okay.
almost everything outside with my son. Yesterday, you want to just
Kavita, can you unmute yourself? Can you mute yourself if you don't have any question to ask?
please send reply mail for the lab. Only waiting on
What? Hello. Yes, Chandan.
So, sir, like, you know, this line could not separate the positive and negative.
Yes, yes.
It's a single line if you print condition, there could be two line process.
Yeah, there are non-linear, but no, two lines also. If you will take, then you have to make multiple cases. Okay. So there are non-linear function which can separate this. Like if there is, let's suppose this is our negative points. This is more complex of that. Okay. And this black one is our positive points. So in this, if you try to separate it using line, you will not able to separate. So there are non-linear curves which can easily separate this. Like this circular curve can easily separate this. So those things we will study in multi-layer perceptron. That is in upcoming lecture videos. So for now, decision boundary when it is a line or linearly, it is not separable. Even if you use two lines, that will be very complex, and you have to define case for like four cases for if you draw two lines here. So that is not a proper way. So there is non-linear curves which can easily separate the XOR gate. And you will also study these things in MLP, that is multi-layer perceptron, in the upcoming lecture. So for this question, like we have four input x1, x2, x3, x4. So what is the thresholding parameter for this? So x4 is in inhibitory input. So whenever it is 1, that is giving our output as 0. So that one case of x4 is ruled out, and this is just a AND gate, that is x1, x2, x3, using x1, x2, x3. When all of the three is 1, then the output will be 1, because y of gx will be 1 when the summation of xi, that is x naught plus x1 plus x2 plus x3. So if this is 1, this is 1, and x2 is 1, and x3 here, if x3 is 1, then this AND gate will give the output 0. So x3 should have to be 0. So the threshold will be 3 here. Okay. Any doubt in this question? Nitin, you have shared some file that is like asking the access denied, request access. Like you have to give access to me, I guess. You can check your mail. I will look at this file and reply back to you. So question 8 we have solved. In this, our x4 is inhibitory output, inhibitory input. In this, our output will be 0 if x4 is equal to 1. Okay, so this is inhibitory input. Okay, so now moving on to the last question of today's lecture that we have already discussed, but we will also discuss some of things. Like which of the following gate is not linearly separable? So can you answer? We have already discussed this question before. XOR, correct. Because AND is linearly separable, OR is linearly separable, and NOR is also linearly separable. So XOR is not linearly separable. And it can be separated using MLP, that is multi-layer perceptron. In this, there will be input layer and different hidden layers, and after that, output layers. So for XOR, and one more thing, we will see why XOR cannot be separated using linear function. Like here, our in for input 0 0, output is 0. This is the XOR truth table. So our equation says that W naught, his first equation says that W naught plus both the inputs are 0. So this will be W naught plus Wixi, that is 0 because both the inputs are 0, is less than 0. Second equation is W naught plus x1 W1. X1 is 1, so it will become W1, that is greater than equal to 0. Okay. See, this is our XOR input x1, x2 output. Output is 0. This means this summation is less than 0 because this is the negative values in the class. Negative class in the datasets. When the output is 1, this means the summation is greater than equal to 0. Okay. So for this also, summation will be greater than equal to 0. And for the last case, again, this is the negative value, that is 0. So it will be less than 0. So our third equation we will get as W naught plus W2 is greater than equal to 0. And fourth equation we will get W naught plus W1 plus W2 equal to greater than equal to 0. Sorry, less than 0. Yes, Alpana, you have raised your hand. What doubt you have?
Yes, sir, I want to ask the single perceptron Boolean function should be linearly separable. Is it right? So for single perceptron, if I'm talking about the single perceptron, then the Boolean function should be linearly separable, no?
Yes, yes.
Okay, sir. Thank you, sir.
But in case of XOR, it is not separable linearly. After
Yes,
that, and or nor all others are XOR and XNOR that are not linearly separable.
okay, sir. Thank you, sir.
Okay. So here we have got our four equation. So this is our equation number 2 and equation number 3. Okay. We can write it as W1 is greater than equal to minus W naught and W2 is greater than equal to minus W naught. Okay. So W1 plus W2 will be greater than equal to minus W naught. It will be, if you add it both, you will get minus 2 W naught. But if it is, and here in the fourth equation, it says W1 plus W2 is less than minus W naught. But here you see that W1 is also greater than minus W naught. W2 is also greater than minus W naught. And how the summation of W1, W2 can be less than minus W naught. So the summation of equation 2 and 3, because W1 plus W2 is, if it is greater than minus 2 W naught, then obviously it will be greater than minus W naught, because minus W naught, because minus 2 W naught is lesser than the minus W naught. Okay, because see, if any number minus 1 is there, if you multiply with it 2, it will become minus 2. So minus 1 is greater than minus 2. So in this way, the summation of equation 2 and 3 contradicts 2 and 3 contradicts the equation number 4. This is our equation 4. Hence, this is not linearly separable. Okay. So any doubt?
So I have a doubt.
Ajit Kumar, yes.
If we have a non-linear input, non-Boolean inputs, then the inputs may be which are most important and which are less important. Then the weights that's assigned to the each input that defines the how the inputs will be important.
Yes, yes.
Okay. So we require to learn these weights.
Yes, yes. We require to learn these weights also, because for important inputs, the weight assigned will be more than the less important inputs. Accordingly, decision will be taken.
Okay.
Okay, then thank you everyone for attending the today's lecture. Or you can ask doubt in the discussion forum also of this course. I will be able to reply there. And this was just a basic lecture, so basic questions was there. In the next lecture, I will try to frame some of the advanced level question apart from the lecture questions. Because in the first week, they have taught only two things, that is MP neuron and perceptron, that is single layer perceptron only. So in upcoming lecture, we'll have very advanced questions. We'll solve advanced questions and we will learn lots of concept through it. So thank you everyone for attending the session. And please try to attend at like 3 or 3:05, because continuously today everyone was attending till 3:40 also. So I was to admit everyone. It is just breaking the continuous way of teaching. Like the teaching become little less smooth. Okay, thank you everyone. Bye bye. We'll meet next Saturday, 3 to 4. And apart from this, there are two more simultaneously TA session is going on. That is on Saturday only 3 to 4. So you will be getting three links. The link will be same every week. You can attend any of the meeting, like from that three. Okay, so now, okay, any Balaji, you want to speak something? Okay, thank you everyone. Bye bye.